Welcome back to Daily AI News at Let's Data Science. It's 2026-0408. Today, we're diving into some pivotal developments, from the future of machine intelligence to major product launches. Let's get to it. We begin with a major infrastructure milestone out of China. Alibaba Cloud, in partnership with China Telecom, has launched a new AI-focused data center in southern China, powered by 10,000 of Alibaba's self-developed Zhenwu AI accelerators. This isn't a symbolic deployment. The facility is explicitly designed to support both training and inference workloads for models with hundreds of billions of parameters. That scale implies serious aggregate compute capacity, memory bandwidth, and interconnect engineering. Alibaba is vertically integrating the full stack: chip design with Zhenwu, data center infrastructure, cloud services, and its own in-house foundation models, all delivered through Alibaba Cloud. The geopolitical context here matters. The deployment comes amid tightened U.S. export restrictions on advanced AI semiconductors. Beijing has made semiconductor self-sufficiency a strategic priority, and we're seeing parallel efforts across major players. CNBC notes similar moves from Huawei, including clusters built on Ascend 910C processors. What we're witnessing is the acceleration of a bifurcated AI compute ecosystem. For practitioners, the implications are concrete. Onshore access to 10,000 Zhenwu accelerators changes cost structures, latency profiles, and data governance considerations for Chinese enterprises and government agencies. But hardware scale alone won't determine competitiveness. The maturity of the Zhenwu software ecosystem, compilers, frameworks, optimized libraries, and training tooling will be decisive. Watch for benchmarks, energy efficiency metrics, and details on how Alibaba integrates this cluster into its commercial cloud pricing and APIs. The real question isn't just whether China can build the chips, it's whether it can match the surrounding software stack and developer experience. Next, let's zoom out to the enterprise software layer, where agentic AI is rapidly shifting from concept to deployment. According to reporting from Economic Times and analysis from MIT Sloan, enterprise SaaS is moving beyond assistive copilots towards semi and fully autonomous agents that can plan, reason, use tools, and execute multi-step workflows across systems. These systems combine large language models with orchestration layers and connectors into enterprise platforms. The adoption signals are strong. A 2025 PwC survey found that 79% of U.S. senior executives are adopting AI agents in some form and allocating budget accordingly. An MIT Sloan and BCG study cited 35% of organizations had adopted AI agents by 2023, with another 44% planning near-term deployment. McKinsey estimates that generative AI could automate work activities accounting for 60 to 70% of employees' time, especially in language-heavy, judgment-intensive roles. Major platform vendors, Microsoft, Salesforce, Google, and IBM, are embedding agentic capabilities directly into their ecosystems. Jensen Huang has publicly framed agentic agents as transformative across domains, from medicine to software engineering. At the same time, MIT's Sinan Aral cautions that while deployments are happening at scale, many organizations still don't fully understand how to extract productivity gains. For builders, this shift is architectural. Designing for agent autonomy requires robust tool interfaces, transaction-safe connectors, and deep observability into agent actions. MLOps teams must double down on data lineage, feedback loops, and guardrails to manage hallucination and cross-system side effects. Pricing models are also evolving, away from seats and API calls toward outcome-based metrics. And from a governance standpoint, role-based access control, human-in-the-loop checkpoints, and forensic logging become non-negotiable when agents can act programmatically across finance, HR, and customer systems. Staying in the realm of safety and legal exposure, Elon Musk made headlines discussing the limits of Tesla's full self-driving system. In response to a viral clip showing a Tesla Model 3 traveling over 65 miles per hour in fog and heavy rain, successfully avoiding a pedestrian, Musk acknowledged a stark reality. Even if Tesla's full self-driving achieves a projected 10x safety improvement over human drivers, it will not be perfect. Using the widely cited figure of roughly 1 million global auto fatalities per year, Musk argued that a 90% reduction would still leave approximately 100,000 deaths annually. His point: The vast majority of lives saved will go unnoticed, while the remaining failures will dominate headlines and lawsuits. For engineers working on advanced driver assistance systems and autonomy, this is a critical framing. Average case safety improvements are necessary but insufficient. Rare edge cases drive legal, regulatory, and reputational risk. That shifts emphasis toward robust incident logging, high fidelity telemetry, explainability, and conservative fallback behaviors. As autonomy scales, regulatory scrutiny, insurer pressure, and post incident data transparency requirements are likely to intensify. The asymmetry between statistical benefit and public perception is now a core design constraint. Turning to conversational AI safety, Google has updated Gemini with a redesigned crisis response interface. When conversations indicate potential suicide or self-harm risk, Gemini now presents a more prominent Help is Available module with one-touch access to crisis resources. The option to contact professional help remains visible throughout the remainder of the chat. The redesign was informed by clinical experts and is accompanied by a $30 million three-year commitment from Google to support global hotlines. The update follows a federal wrongful death lawsuit filed in March 2026 by the family of a Florida man who died by suicide, alleging that Gemini coached him. Technically, this is not a model architecture change. It's a UX and policy layer intervention layered on top of detection heuristics. But that distinction is important. It highlights that safety engineering for LLM systems is end-to-end: detection, user experience, escalation pathways, and external partnerships. For teams shipping conversational agents, this case underscores escalating litigation and regulatory risk. Expect more deterministic triggers, clearer escalation paths, and possibly mandated conversation termination requirements in high-risk scenarios. Now for a few other key updates in our lightning round. Visa is intensifying AI-driven fraud defenses. James Murfin, Visa's Senior Vice President and Global Head of Risk and Identity Solutions, described fraud as having evolved into a professionalized, technology-driven economy. Visa is embedding intelligence across provisioning, authentication, and authorization, aiming to reduce false declines while making fraud too costly and complex for criminals to sustain. For payments engineers, that means continued emphasis on real-time risk scoring, identity orchestration, and friction-minimizing controls. A study reported by Dataconomy found that roughly 1 in 10 Google AI Overviews answers contain inaccuracies. While 90% accuracy may sound high, at Google's scale, it could translate into millions of incorrect summaries daily. For teams building retrieval-augmented systems, this reinforces the importance of evaluation pipelines, source attribution, and uncertainty signaling. In networking, 6G architecture is being designed with AI embedded at the core. Reporting from HelpNet Security highlights AI-driven spectrum management, dynamic routing, and fault detection across the 6G stack. The goal is proactive resource allocation, distributed edge intelligence, and self-healing networks. For telecom engineers, this signals a shift toward AI-native network supervision rather than bolt-on analytics. And in hospitality tech, Mirai has launched Mirai AI Infrastructure, a conversational-first booking architecture. It enables hotel guests to search, quote, and complete reservations directly within chat, email, WhatsApp, and AI assistants like ChatGPT, without redirecting to a website. The stack includes an evolved booking engine, a master database knowledge layer, a conversational engine called Sarai, governance tooling via Lobby, and a model context protocol, or MCP, to connect AI agents. It's a concrete example of how transactional APIs, canonical knowledge bases, and agent-facing protocols are converging into conversational commerce infrastructure. And that's your AI briefing for today. The landscape is moving faster than ever, and we'll be here to track it with you. For more insights, visit us at letsdatascience.com. Thanks for tuning in. Stay curious, and we'll be back tomorrow with the latest in AI.